Hey guys, welcome back to Consistent Code. So today's problem of the day is lexicographically smallest string. Basically what the problem is that we are given a string which is having only lowercase characters. Now we need to find a lexicographically smallest string after removing exactly k characters. And also we need to correct the value of k by, if the given string's length is a power of 2, then we need to reduce k by half, and otherwise we just need to multiply k by 2. So let's first do this thing only to correct the value of k, because the main question starts after this. So to correct the value of k, what we can do, we can first just check. Let's say that n is the size of our given string, and now we just need to check if n is a power of 2. To do that, what we can do, let's create another variable. Let's say n equals to n. Now we will just check if n mod 2 is a 0, and if it is divisible by 0, then we are just gonna divide it by 2. And after that, if this n is less than or equals to 1, that means this is a power of 2, because you can just see, if I have 8 which is a power of 2, if I divide it by 2 it will be 4, if I again divide it by 2 it will be 2, and finally it will become 1. So any length which is a power of 2 will in the end become 1. And if it is not a power of 2, let's say 9, then if I divide it by 2, if it is not divisible, then it will remain 9 here only. Otherwise, if it was a 10, it would have become a 5, and now we cannot divide it by 2. So it is greater than 1. Hence, the condition to know if it is a power of 2 is that n should be equals to 1. So I have just put n greater less than equals to 1. That means this is the power of 2, and we need to multiply k by 1. Sorry, k by 2. So I'm just gonna right shift k by 1, and otherwise we just need to uh, we left shifted k by 1, and otherwise we will right shift k by 1. Now once we are done with this thing, we have the value of k corrected. So now we will move on to our main question to find the lexicographically smallest string. Okay, so to do that, we also need to check this thing, that if it is not possible to remove k, that is the value of k after correction. Now that we have the value of k corrected, we need to check that our string length should be greater than k. Only then we can correct the string. Otherwise, it will become empty, or the value of k is greater than the string. We have to return a -1. So initially, we are just gonna put this condition also, that if the n is, or I can say that if the value of k is greater or equals to n, I can simply return a string -1. Otherwise, now we need to solve the main problem. So for solving that, let's consider string answer, which will be our final answer. And now let's check out the intuition which we're going to follow by considering this example foolan. Let's consider this example case. So now what can we observe here? So we want a small, the lexicographically smallest string by removing k characters. We have already checked that if k is greater or equals to the size, we have returned -1. But in this case, the size of s, or I can say that n, which is the size of s, in this case is a 7. So now what we will do in this case, we need to remove 4 characters. So let's see, if we start right here, just consider like o and l, right? So one option is that we can remove these two o's, and right, if we remove these two o, other option is that you can remove this l also. Or let me just give you one intuition first. Suppose we have to remove only one character, right, and our string is this only, Then suppose if this A, you remove this L, then A come here, so you will get the string FOOAND. And otherwise, if you remove this O, FOLAND, right? So you can see that L is also lexicographically smaller than O, and A is also lexicographically smaller than L. But out of these two strings, which one will be the lexicographically smaller? That is, of course, this one. So what do you observe from this? That we need to first remove the character on the left side. In this case, when we removed O, then O is left, and when we removed L in the case of this A, then L was to the right of O. So first we need to remove the character which is at left side. So what do we get from this? That we can start iterating from this left direction and check if we have any lexicographically smaller character, and the previous character was lexicographically larger, then we can remove that character until we have value of k greater than 0, right? So now we start iterating. Since our answer is empty, we can initially just put f directly here. Now you can see the next character is O, which is lexicographically greater than O. So we will do nothing and put it also. Then we can see there is another O, then we can put this also. Now we find that we have a character L. So what we will do here, since L is lexicographically smaller than O, we can just remove the previous characters until we do not find a character which is lexicographically smaller than L. So since O is lexicographically greater than L, we can just remove these two O and put L here. And by doing this, we have also updated the value of K2. Since we have removed two characters, this will now become 2. So now it is a 2 only. So this becomes 2. Now we are at this position. Now we have an A here. So what we will do, we will again check in our answer that if the previous character is lexicographically greater than this. So we can find that F and L are both greater than L. So we will remove both of them and put an A here. So now we will put an A here, and the next character is N, which is lexicographically greater than A, and the next character is D. Now D is lexicographically smaller than N, but we cannot remove this because when we removed the previous time when we removed, then we have also removed two characters, and hence this K is now 0. So let me just make it a 0, right? So now since the value of k is 0, we cannot remove anything, and the final answer which we got is a and d, and you can see it here also that final answer is and. Now I hope you have got the intuition of this approach, and now let's try just implement this by writing the code. So initially what we need to do, let's create a variable I equals to 0 to iterate over the string. And then what we need to do, that we need to run a loop while I is less than n, and also we want that k should be greater than 0. That is, k is the number of characters which we can remove. If there is no character which is left to remove, then there is no need to, you know, iterate over the string again, and we can just simply put the remaining characters in the string. So now I will check if our answer is empty. Then what we will do, we can simply add this thing, that is as of I, and increment I by 1. Otherwise what we will do, we just need to check if our previous character was less than this character, that is our current character, then in that case, what we will do, we will just pop back the previous character, and we will uh, okay, we will just pop back the previous character, and that's it. Otherwise, we can just put this character in our answer, right? And after this loop is completed, this loop ends only if either I becomes greater than n, that is we have iterated the string completely, or we have removed all the characters, and so if there are characters left in our string, we can simply add them. So we can just say while I is less than n, I can simply write answer plus should be equals to s of I plus plus. That should be it, right? Now we can just simply return our answer. So that should be it. And one more thing, it should be not less than greater than s of I, because the previous character needs to be lexicographically greater than the character the si which we are at now, uh, so that we remove the previous character so that we can make a lexicographically smaller string. And one more thing was that we just did the mistake here also, that this should be, if it was a power of 2, we have to reduce it by half, and otherwise we needed to left shift it by half. So now let's compile and run this code and see if this is working. And we are getting some error right now. Okay, so one more thing is that before we put all the remaining characters in a string, we also need to remove any character. There can also be a case when k is greater than 0 and I is less than n. That is, we have iterated the string completely, but we have not removed any characters. In that case, what we will do, while we have k, we can just pop back from our string and increment, not increment, just decrement k. Right now, it should be working fine. Just compile and run this again. So now, and one last thing which is left is this, when we popped here, we need to put a k minus minus here also. Now let's try compiling it one more time. And now we're getting correct output. Now let's check for the another test case also, and then we will submit this code. Okay, it's correct. So now let's submit this code. So we have solved this problem successfully, and I hope you liked the explanation, and if you did so, make sure you hit the like button and subscribe to the channel, and I will see you tomorrow with the next problem of the day.